All right, I just got my kids in bed. It's 10 o'clock on a Thursday night. What am I going to do? I want to do some physics. Yeah, we're going to do example number 4 from our friction examples here. We're pushing a 38 kilogram box along with a force of 800 newtons, and it is accelerating at 1.8 meters per second squared. We want to find the force of friction in order for this to happen. All right, well, you know, I see a lot of stuff about forces here, so I'm going to draw a free body diagram. That's always the first thing I'm going to do if I read stuff about forces. So I know in this case I've got the force of gravity down. I've got the normal force up. It does say that I'm pushing with the force of, so this is the force of me, which is a normal force, but force of me, which it does say is 800 newtons. That's fine. And then it does say that there is friction. So the question is, how much friction does there need to be in order for this to be the case? Now, in order to do that, we're going to write an equation, right? We do the free body diagram, then we write an equation. So the equation we're going to write is the force of me, which is to the right, and then we're going to subtract the force of friction because that's to the left, and that needs to equal ma. So we'll go ahead and put my force in there, which was 800 newtons. We'll go minus the force of friction equals, we got a 38 kilogram box, and we've got an acceleration of 1.8 meters per second squared. Now we'll go ahead and multiply those. So we'll go 38 times 1.8, which will give us 68.4. So we'll go 800 minus F equals 68.4. And then we'll subtract the 800 there. And that will give us that the negative friction is equal to negative 731.6. Divide both sides by -1, and I know that friction is 731.6. You could write 732 newtons, just like that. How about them apples? We just got the force of friction. All right, the next question is, letter B, the coefficient of kinetic friction between the box and the ground. All right, well, if we're pushing it, then it's sliding along the ground, right? So it's got to be kinetic friction. It's not static friction. Now, in order to find that, we need to connect the force of friction with the coefficient of friction. And so what we're going to do is we're just going to say, well, the force of friction equals the kinetic coefficient of friction times the normal force. And that's what we learned in class today. And we'll go ahead and solve for that. Now, in order to do that, we are going to need the normal force there, right? And so to get the normal force, we can look at the vertical forces. The normal force is a vertical force. And you can do one of two things. You can either recognize that those two things are equal, and we can solve for Fg. Or, if you want, you can write your equation. You can go Fn minus Fg, because Fg is down, equals ma. But, of course, the acceleration is 0 for the vertical direction. And so we end up getting that Fn, add the Fg to both sides, equals Fg, which is lovely. Fg, of course, is equal to mg, which is the mass, which is 38, times 9.8. And all of that will equal the normal force. So we just take that 38 there, and we multiply by 9.8, and we get 372.4. Now we can put the friction into this baby right here, and we'll take the normal force and put it into this baby right here, and we end up with an equation that is 731.6 newtons is equal to the coefficient of kinetic friction times the normal force, which is 372.4, and we just divide 731.6 by 372.4. And we get that the coefficient of friction is equal to 1.96. So that's a pretty high coefficient of friction there. All right, that's it. That's all we got. Okay, so hopefully that was helpful. You've seen some friction. You've seen some coefficient of friction. Let's go on to the last question, all right?